Hello everyone, my name is Iru Nam. From this video, I would like to give an introduction to structural mechanics course. This course is also called structural analysis. I would like to start from elements and forms of structures. There are two types of structural elements. First type is beam. Beams support external loads applied along with a direction perpendicular to the longitudinal direction. In the figure, the typical type of beam is given. The left-hand side is supported with hinge and another side is supported with roller. Another type of structural element is column. Column support compressive load applied along with vertical direction. There are various types of structural system, and the first form of structural system is truss. Truss is a type of structure joined with slender members, which are narrow members. A basic form of a connected member is triangle. Another form of a structural system is cable and arch. Cables mostly support tensile forces, whereas arches support compressive forces. In the bottom figure, the typical type of a cable is shown in the image. We can find these cables in cable stayed bridge and the suspension bridge. Also, in the figure, it shows arch structure. We can find this arch structure in concrete bridge. So in this part, the frame structure is introduced. We can find this frame structure in typical building structures. Frame members are subjected to axial, shear, and moment loadings. Also, this is another form of a structural system, surface structures. Surface structure have much thinner surface thickness than other dimensions. From now, I would like to talk about mechanical terms to be determined in this course. There are main two kinds of primary terms to be determined in this course. The first kind is internal loadings. As shown in this figure, we have a frame structure. Our principal interest is to determine internal loadings at certain point of a frame structure. To determine these internal loadings, we cut this frame structure at certain point. This frame is cut along with the cross-sectional direction, and at this cross-section, we have three different kinds of internal loadings, such as axial force N, shear force V, and moment M. And these internal loadings can be determined by equation of equilibrium, and also these internal loadings can be found at other points of the frame structure, and we collect those internal loading data, and based on this data we can construct shear force diagram and bending moment diagram. And another kind of primary term is deflection. Deflection is defined as a distance between a point at initial beam and a point at deflected beam. As shown in this figure, concentrated load is applied at the free end of cantilever beam. And this initial beam is shown as blue line, and deflected beam is shown as red line. before this concentrated load is applied, the beam is remained as a blue line, and after the load is applied, the beam is deflected to red line. So deflection is defined as a distance between a point at the initial beam and at a point at deflected beam. From now, I would like to talk about course outlines and objectives. This course, structural mechanics, mainly divided into two parts. First part is structural mechanics 1, and another part is structural mechanics 2. Abstract of this structural mechanics 1 is given here. Student will learn how to analyze structures by hand to determine reactions, internal loading, such as axial load, moment, and shear, and deformations that result from arbitrary external loadings. The analysis will be carried out for various types of structures, such as truss, frame, arch, cable, and compound beam, and so forth. Both determinate and indeterminate structures will be studied. Contents of this structural mechanics 1 is given here. Student will study types of structures and loads, also study analysis of statically determinate structures, analysis of statically determinate truss. Also, student will study internal loadings and shear force bending moment diagram, cables and arch influence lines, approximate analysis of statically indeterminate structures are studied. Also, student will study how to determine deflection value by using double integration method and moment area method. Also, student will study how to determine deflection by using energy method. Energy method is divided into two methods, virtual work principle and Castigliano's theorem. Also, analysis of statically indeterminate structure will be studied. And also, student will study how to determine the moment value using displacement method, such as slope deflection method and moment distribution method. There are three main objectives in this course. First objective is to explain the difference between determinate, indeterminate, and unstable structures, and identify whether a structure is determinate, indeterminate, or unstable. The second objective is to understand and successfully apply the following structural analysis method, such as method of joints, method of sections, virtual work, influence lines, Porter method, force method, slope deflection method, and moment distribution method. Third objective is to choose an appropriate structural analysis method to determine the internal forces or deflections of a structure with a given set of loads. As an extension course of this structural mechanics 1, structural mechanics 2 will be provided. The main topic of this course includes analysis of structure using matrix displacement method. Also, the main topic includes calculation of structural dynamic responses due to arbitrary external loadings. Also, one of the topic is to solve stability problems with equilibrium or energy method. Also, main topic includes determination of structural ultimate load. The contents of structural mechanics 2 course is given here. Students will study element stiffness matrix, global stiffness matrix, equivalent nodal forces, and also students will study structural dynamics parts. And this structural dynamic part includes free and forced vibration of systems with single degree of freedom, and the effects of damping, free vibration of system with multiple degree of freedoms, harmonic excitation analysis of system with 2 degree of freedom, and also structural mechanics 2 course includes stability analysis. This stability analysis will be carried out using equilibrium approach and energy approach. And this structural mechanics 2 also includes determination of ultimate stress, ultimate state loading, limit moment plastic hinge and ultimate state, and ultimate load of statically indeterminate beam structure will be studied. There are 4 main objectives in this course. First objective is to interpret the procedure for structural analysis with matrix displacement method. Second objective is to understand the fundamentals of dynamic characteristics of structure and determine